Good afternoon. It's a pleasure to be here, and I would like to thank you for the opportunity to show my work. In my PhD project, I'm going to make 3 genomic association studies. This is the first of them, which we collect phenotypes in live animals, and it is entitled Genome-Wide Mapping of Loss Affecting Carcass Predictive Traits in Brazilian Nelore Cattle. We are interested in carcass traits because the first return that the farmer has, it is the payment received by the weight of the carcass in the slaughterhouses, and because the previous studies have shown the relationship between traits such as weight, conformation, precocity, and muscling with meat yield. But carcass traits are difficult and expensive to evaluate in breeding programs. Sometimes require slaughter or ultrasound use. Then, in this context, information of molecular markers may be useful. Before that, the objective of this work was to evaluate and identify putative genomic regions, explain difference in birth weight, conformation, precocity, muscling, and weight at weaning and year in Nelore cattle by genome mapping. For that, we genotype 788 Nelore with high-density chip from Illumina, that contains more than 700,000 markers. For the quality control of the markers, we use a minor allele frequency greater than 2%, Fisher's exact test p-value for Hardenberg equilibrium greater than 10 to minus 5, and cow rate of at least 98%. For obtaining CPM phenotypes, visual scores, evaluations were performed, giving a score 1 to 5 for each characteristic evaluated. After, it was calculated the EBVs, the regressed estimated breeding values, to get the animal's own phenotype. In each model, phenotypes were adjusted to contemporary group and age of the animal and cow, or just for the contemporary group and age of the animal as fixed effect. You can see in the second column here, the fixed effects. And we have the heritability for these phenotypes, and in the last column, the genotypic variance explained by these markers. We have done 1 single trait and 3 multi-trait association analyses and chose the best one. Single trait association analysis was done through an adaptive mixed model to test each SNP for associations. The same model, Y in function mean plus SNP plus animal plus error, was applied across traits. For multiple traits association analysis, 3 different approaches were applied in order to identify putative markers with pleiotropic effects. The first method consists in the computation for each SNP of the test statistic. Is this statistic test the first function? The second approach consists in the meta-analysis of p-values by the Stauffer method. The next one is statistic test. The last approach was based on the IgG decomposition of the phenotypic covariance matrix, like a principal components analysis, the last one. Differences in power between single trait and multi-trait analysis were evaluated by the comparison of the false discovery rate, FDR, across analyses. For the functional analysis, we use Biomart and database assembled genes to generate a list of candidate genes and David and string for functional enrichment analysis to visualize possible pathways and interactions between genes and its proteins. After the quality control, we had more than 500,000 SNPs in this analysis. And the method that showed lowest FDR was the Stouffer method, we call 6.4%. So we used it. This is the Manhattan plot. This is the Manhattan plot for this method, Stouffer, and the significant SNPs appear above the threshold line, that the alpha is equal 10 to minus 5, with the most significant SNP found in chromosome 14, in that position, near PLAG1 gene. The results of the association analysis showed 44 regions across the genome where significant correlate with the phenotypes. These regions are distributed across 18 chromosomes in total. When we investigated the candidate genes, we found 459 genes in total, which 306 are known or known by projection, and 320 are in the same big chain with the 240 interactions. This output obtained to a string, but not shown here. When we used David, we found 12 genes in the somatotropin cluster with the highest score, and all of these genes are expressed in the embryogenesis phase, with expression in placenta and umbilical cord. 9 of these genes are from BTA23, starting with PRP5 in 34.38 megabases and finishing with CSH1 in 35.06 megabase. This region needs a special attention because it can be a strong QTL for these traits. This is the output from David. We have the main 12 genes. 2 of them are from chromosome 14. Like I said, 9 of them are from chromosome 23, and the last one is from chromosome 28. This is the output of string to show the interactions between the main genes found in this study. We introduced the IGF-1 and IGF-2 genes because it is known that they are related with weight and growth traits. No associations were found between these two genes and the traits, but this is explained by the fact that there isn't variation in these regions nearby these genes, but there is association with the genes controlling its expression, like we found variation in PLAG1, CRH, and CSH1. Here a brief description of the main genes found in this work. SBSPON have been associated with mitosis because he controls central biogenes in segregation. In some studies, these genes has been associated sometimes of cancer in humans. FEM213A maintain bone mass by inhibition of osteoclast formation by redox regulatory activity, and is induced by estrogen that can explain the expression of this gene with bone formation during embryogenesis. CRH is a growth inhibitor as it plays a role in ACTA and cortisol release, increased levels of cortisol actuate in metabolism inhibition glucose uptake, and simulating the breakdown of fat. CSH1 and prolactin receptors are somatotropin members of the growth hormone prolactin family. Prolactin can activate or inactivate growth hormone binding to its receptor sites. CSH1 influencing growth appears to be through control of IGF-2 expression. In some studies, this gene is related to Silver-Russell syndrome in humans, described as a problems in growth in humans. About the PLAG1 gene, in many studies, gene is strongly associated with weight gain, puberty, height, and fat deposition. Then the conclusion of this study, we found evidence that a breeding program which selects for those 9 carcass traits are actually selecting for weight. I would like to thank you, my collaborators, especially the coordinator of this research, Professor José Fernando Garcia from Unesp Araçatuba, and the financial and technical support of those companies and agencies. Thank you for your attention.